Alright. So what we're going to do now is we're going to go over the different methods for charging this unit for refrigerant. We covered the refrigerant, but we haven't pulled the vacuum on it. So I'm going to run the vacuum real quick and not run a deep vacuum, but I'm just going to run a vacuum on it for procedure wise. And when we charge through the yellow hose. We pull a vacuum through the yellow hose. But what I like to do is I'd like to pull the vacuum from the red hose. And I'll show you something here. Now the problem is if I'm going to pull through the red hose, it's going to come in the gauge and pull from the blue, but if this is just hanging out here, it's just going to suck air in. It's not going to do anything. But what I like to do is I like to hook the yellow hose to my tank here of my new refrigerant. And guys, don't use pliers or wrenches on these. Hand tight, but tight them good, but hand tight, okay? So what I want to do is I want to pull a vacuum. And when I'm pulling a vacuum like this, the vacuum's going to pull the vacuum all the way up to this tank. So there's no air in here. So if I had the vacuum pump connected to the yellow hose, I could pull the vacuum on the refrigerator all day. But when I'm done pulling the vacuum, I need to take the yellow hose off and move it over here for charging. And that lets air back into my hose. I'm gonna show you. Normally when you're working on a system, and let's just say we're going through the low side only, we want to pull the vacuum. So we're like this. We hook up this yellow hose here. Oops. Turn the vacuum pump on. I'm going to open this up. You hear the noise? Yeah. That's still air and moisture and stuff in the system. And we showed in the last week, we used a micron gauge to show the real deep vacuum. If you listen, the pump will start getting deeper and deeper in noise. When I close this, listen. You hear the pump change noise? Yeah. Watch. Okay, if I'm hearing gurgling, there's still stuff in the system coming out. That gurgling is the oil in the pump, and whatever air or moisture or even a little bit of residue freon that's in there is coming through. So we're just going to wait a minute and wait for it to pull down that deep vacuum so it gets quiet. Okay, you notice I put my finger on it, you don't hear it? Sometimes you put my finger and you go like this, you hear it. Psst. Right now it's really low. So just because it says 2930 on this gauge, remember when I point? I say 2930 on this gauge right here. That doesn't mean I've reached the vacuum that I want to reach. Okay? The noise is getting deeper now. Listen, wait. You hear it getting deeper? Mm-hmm. Okay, let me just explain this one thing and I'll take your question. So let's just say I pulled my vacuum, my micron gauge was hooked up, and now I got to charge. Well, we charge through the same hose I pulled the vacuum on. But if I take this hose off now, the vacuum that was in this hose is gone. Now air got in. Remember, it was hooked up to the vacuum. I closed it here, so from the blue hose to the fridge is still in a vacuum. It's still showing a vacuum here. Yeah. Okay? But when I take this hose off, this hose is filled with air. So when I connect this tank up, if I open up the Freon tank, the air in this hose is going to go into the refrigerator too. So we're mixing Freon with air that's in this hose. So we don't want to do that. So I always like to do this so I don't have to disconnect and connect, is I go with this red hose, leave the yellow hose on the tank, and while I'm pulling the vacuum here, not only is it pulling the vacuum on my refrigerator, but it's pulling the vacuum on my yellow hose so that my hose has no air in it too. So when I close this gauge here, I close the red gauge like this hose has no air in it, this has no air in it. I don't have to disconnect the pump and connect the tank. Right now, everything's evacuated. What was your question?
And this is another thing I was concerned about too. You know, when you hook up on the low side and the high side when you're pulling it back, right?
Yes.
So now on the high side, you're more or less, I'm thinking that you're more or less like pulling from
The condenser.
The condenser. But now, if you're just doing the low side, that still, you still getting the maximum.
The whole system.
The whole system as well.
But remember, the low side is going to pull from the high side through that capillary tube. So your vacuum pump is trying to suck that through the capillary tube.
Mm-hmm.
Okay, there's valves in the compressor that don't allow the pressure to go back through the compressor from here to there. They're separated by the pump.
Okay.
Okay, so the only way that low side is going to pull from the high side is if it goes all the way around the odor loop or the hot gas loop, through the dryer filter, through the capillary tube, and then through the evaporator down through the suction line. So it is better to recover from both sides. But this valve is no good. We changed the core on it the other day, but it still doesn't read pressure, so that valve is garbage. I put a brand new core in there and it's still not working.
So when you vacuum, and you always gotta take it from the low side, always?
When you're vacuuming, if you only have one hose, you really want to do it from the low side.
But you could do either or.
You could do from the high side, but it's gonna take forever to get the freon out of the low side. Because now you're trying to go back through the capillary tube the opposite way it normally flows. Okay? Remember, evacuation is important, but we did not talk about when we recovered, and we recovered today. We recovered because we have to do a repair. We're replacing the compressor, replacing the condenser, putting in a new dryer filter. We're changing something in the system. So we had to recover the freon and put in a recovery tank. Now that we recovered it, we can service this unit. We can replace the condenser, the compressor, the dryer filter, whatever we need to replace. A lot of people go right into pulling the vacuum on the system after that. That's not the way it's supposed to be, because when you service a system, you change the filter, or the condenser, or the compressor, you've exposed it to air, just like disconnecting this hose from the pump and moving it here, you allow air to get in. Okay? So you say, yeah, well, that's why I'm evacuating. That's why I'm pulling the vacuum, because I want to get that air out for service.
Air and freon can't mix. What?
No, you don't want to mix
Yeah,
that.
you don't want to mix it.
Because it has moisture in it, and that can cause restrictions. Now, what you want to do after you serviced it is you want to take nitrogen and put 100 psi of nitrogen in here first, not vacuum it. You want to put pressure. Then, if you change the compressor, and these are the two joints you replace, you put a valve, you put a new filter, while it's under pressure, the whole system is at 100 psi, not just the high side. Where normally when a refrigerator runs, the high side's at 100 and the low side's at 0.
Yeah.
Okay? But when we put 100 psi, the compressor's not running and the whole system is 100 psi. We don't need the compressor running. And then we could take soap and test every one of these braze joints with a little bit of soap, and if they bubble, we know we have a leak. Yes?
I seen some on that video, which is a real good video, that Electrolux video on seal system. Nitrogen purge. What does that mean? Nitrogen purge.
That means like when the lines are open and you run the nitrogen through and let it blow out the other side, so it just blows out any debris. You're purging the system. You're cleaning it out. You're not recovering it. We don't recover nitrogen. When we're done, like right now, if we charge it with nitrogen, we check for leaks and we put soap on every braze joint in the system and we didn't find any leaks, then we can just let that nitrogen out in the air.
I was thinking too that when you do that purge, like when you do a seal system, when you check for leaks, you let it, like say, you might have a unit that might come in and say, okay, this need a leak check. Or okay, well my refrigerator's ran out of refrigerant. Okay, so I've done the nitrogen purge up to 100 psi on each side, and I let it sit.
Well, wait.
Let it sit.
Putting 100 psi in here is not a nitrogen purge. Okay, purge is, this is not connected.
Right.
and I put nitrogen on the low side and I let it flow through the system and come out the other side to flush the system out. That's a purge. You're purging it out into the air. When we're charging the unit, don't eat the wrapper with the video. All that crackling's going on in the video now.
Sorry.
So when you put 100 psi in here, you let it out, but you're not necessarily purging it. You're pressurizing the system. It's like this tank. I put 100 psi in this tank. I want to make sure the tank's not leaking. But in this case, this is our tank. It's just pipes throughout the whole system. Okay, so you want to rephrase your question or ask it again?
Yeah. Well, actually, just pressurizing the system to make sure I don't, you know, like I said, like, you know, people come in and say, okay, this got a leak. Some techs might send a refrigerator in and say, oh, do a leak check on it. You know what I mean? It's like we charge it such and such a date or whatever. So the first thing I would do is go ahead and purge it. You know what I mean? I would change the dryer, you know, do all that stuff you just explained and stuff like that. Then I purge it. And 9 out of 10, you know, that's been happening lately. It's been restrictions. You know, it's got a leak.
Yeah.
You know what I'm saying? Just restrictions. You know, I let it sit overnight. You know, and it's still at 100 psi, pressurized 100 psi on each side, and nothing has leaked out overnight. You know, so and I just go ahead and just. You know.
Well, remember they say that you charge it with nitrogen to leak check it. Okay, but that is to pressurize the system to make sure that there's nothing in it, and we're going to let that out. Okay, so. You say in purge, but I think you meant to pressurize the system. Okay, purge, like let's say we think the capillary tube's clogged. We could put 100 psi on the low side and cut the capillary tube at the dryer filter and see if anything comes out the capillary tube. If I don't like to cut it because it's too short here, but from the factory, this capillary tube here might be, let's say, 3 or 4 inches long. Okay? Yeah, so then we want to cut this capillary tube here and put nitrogen in here and let it flow through the evaporator and come out that capillary tube just to make sure that the capillary tube's not restricted. If I get very little or no pressure coming out of the capillary tube, then I know, hey, I got a restriction.
So the whole point of nitrogen going into the refrigerator is to check for leaks and to.
That's all nitrogen is, because nitrogen, one of the EPA test questions, by the way, is type 2 certification, is that after installing a field pipe split system, that's the words they use. And when I say field pipe, is because you got a piece inside the house, the air handler, and you got the condensing unit outside. And when they build a house or they install a unit, they have to run lines from one unit to the other. The 2 units could be right on the same wall, one outside, one inside, or one could be on the second floor and one's on the first floor. So field pipe split system means a system split in 2, unlike a refrigerator where it's all in one piece, and you have to put the pipe in. So they say you're going to pressurize it with dry nitrogen and leak check it before we evacuate the system for service. So whenever you change a compressor, dryer, filter, whatever, we don't pull a vacuum on it right away. We put nitrogen in. We don't want to go over 100 psi. Does anybody have an idea why we don't want to go over 100 psi?
You might.
It'll
Bust the system.
The evaporator is made of aluminum. It's the weakest point in the system. I've had people bust the evaporator by putting too much pressure. If you read the model and serial number plate, and I think it was you that were asking me about those pressures. Was it you that asking me about the test pressures that they put on the model and serial number plate? The test pressures are the low and the high side pressures that the factory tests the system out to see if the system has any problems. But they don't put no more than 100 or 200 psi in the low side or the high side to make sure that that side of the system's not leaking. Okay? But if you want to test it, I say 100 psi is enough to check the whole system for leaks.
So that would putting nitrogen in the refrigerator would probably be the first thing you do before you remove anything, basically.
No, the first thing to do is you recover it.
Yeah, you cover it.
Then you put nitrogen and check to make sure nitrogen's not leaking.
Okay.
And a lot of things, what you do, and remember what we did on the other refrigerator out there, is the needle was pointing at 0. We put a piece of tape on the face of the meter, and we drew a line on the tape right where the needle was. that you could do what they call a drop test. If you had the time, you put 100 psi of nitrogen on there, and then you leave it there. Then you tell the customer, look, I think this has a leak internal or something. You put 100 psi in there, leave the gauges on there, say, listen, I'm going to run a couple of calls. I'll be back about 3 or 4 o'clock in the afternoon. I want to see if that needle dropped. The gauges, I think they're still connected, but you would just take a piece of tape, lay it on the face here. Give me a piece of tape. There's masking tape out there, right?
There should be, yeah.
I'll show you what I'm talking about. So just pause it. Just hit pause on it.
Can I say something else too?
Yeah, go ahead.
When you say recharge,
Recharge means to put Freon back in the
Put
unit,
back in.
make it ready for reuse.
okay.
Okay, so you asked, we're talking about putting nitrogen in the system for checking for leaks, and you're talking about putting dye in the system. And what was the other thing you said?
Dye or either what we call a sniffer.
Okay, now, I don't want this on the recorder. So, what happens between putting nitrogen in and then putting dye in the refrigerant? There's nothing wrong with putting dye in, but if you get dye in your gauges, it's a mess everywhere.
Exactly.
And when you put dye, usually you're putting dye with refrigerant.
Exactly.
So if you have a leak, you're charging the system of Freon. Let's say you find a leak, now you have to repair that leak.
Exactly.
So the reason why we put nitrogen is not using Freon. And it's dry so it doesn't contaminate the system. So when we
Exactly.
charge it with nitrogen, we leak test with just pressure and see if that leak test shows that the pressure's dropping, or we soap test our fittings and it bubbles, then we can fix it. If we want to put Freon in with dye, what do we do before we put Freon in?
Vacuum.
We vacuum the system. Now, if it's our system's leaking, if we have a hole in any of our joints and our vacuum pump's running, what's happening to our system at that time?
It's becoming
Well, the vacuum's pulling,
exactly.
but if I have a hole right here, what's happening here?
It's sucking in.
It's sucking in
It's
air.
sucking air and
Air.
moisture back into my system, and I'm already contaminating my system with air and moisture. So by charging with nitrogen first, it leaks out instead of sucking air in.
Exactly.
We don't pull moisture in. So
Exactly.
that's the purpose of putting nitrogen. Yes.
All right. So when you said put it through the capillary, right? The nitrogen. What line?
Well, we put the nitrogen in the system.
In the
It's going to
system.
flow around the whole system. What I was talking about with the capillary is, if you thought there was a restriction in the system, then we would cut the capillary and
Exactly.
see if we got nitrogen coming out. We would
Exactly.
have this low side.
And then it would go all the way through, right?
I don't want that on the tape.
So what about being able to detect? Because I've seen a lot of techs have issues when they do the LGs, where they have an issue with the condenser
Mm-hmm.
or the evaporator.
What do you mean an issue? Can you be a
I
little
mean, as
specific?
far as leaking.
Okay, so if you had a condenser leaking, that's why we want a nitrogen test.
Exactly.
Now, if you don't know it's the condenser or the evaporator, you're going to have to isolate your system. Okay? Usually that means taking the line off the compressor, the high side, and then right here, we'll just close this off. We'll take this off the dryer filter, we'll close this off, and if I put a valve on here or put a valve on here, I just pressurize the high side. First thing I want to do is nitrogen to 100. Let's see if it drops. I don't know what I did with that tape. I went and got that tape and I lost that little piece of tape at the time I went to get this tool. So if I pressurize this to 100, this gauge goes to 100, I put a little piece of tape there and mark it right where the needle's at. And if I see the needle has moved down, I know my system's leaking, then I have to find the leak. So before I isolate it, I pressurize the whole system and I wait to see if that system drops. If that system drops, then I know the system leaks. If I can't find it with soap, then I want to go ahead and isolate it and separate the high side from the low side. Say, oh, my high side's leaking or my low side's leaking.
Okay, got it. And
Okay?
then you can
With a dye, you have to have the unit running. And here's a couple of problems when you're using the electronic detector or a dye. You go ahead and you fill the thing up with Freon, but what is the low side pressure, guys, when the compressor's running? Anybody know?
But
Zero.
About
yes,
zero.
yeah, zero.
So when the compressor's off, I'll have 30 to 40 PSI, but when it's running, my low side's only reading 0 PSI. There's no pressure on my low side. So then you're like, well, if it's at 0, that means the pressure inside the pipe is the same as the outside. There's nothing leaking out for the detector to detect. And if it runs long enough, it actually pulls into the negative, and now it's sucking air in on the low side. So again, that's another reason why you have nitrogen. If you want to use electronic leak detector, the EPA says you can put a small trace gas of Freon. So you can put like a half an ounce of 134A in there, then fill it with 100 PSI nitrogen. Now use your electronic leak detector to find leaks. But if you don't do it with the compressor running. That's the reason why we use nitrogen, because the whole system is at 100, even the low side.
Okay, so I'm gonna play devil's advocate, right?
Okay?
All right, say you got the system running, you're filling it up with Freon. What is the advantage or disadvantage of using a thermal gun? You know how people use the thermal guns, watch it fill up to see if it.
I just put my hand on the condenser.
Okay.
I don't know exactly what they're checking, the compressor heat or checking this and that. The compressor relies on refrigerant flow to keep it cool.
And I'm talking about the visual, the ones that have the ones that actually show.
Yeah, the laser thermometer. But what are they? They got it
Not
on
the
the condenser?
thermometer. No, the image.
Thermal imaging.
Thermal imaging. That's the one.
Okay, so I guess what they're trying to do by thermal imaging is it turns red with heat. You know, so they want to see that this whole thing's. I go like this in my hand. What am I going to spend money on a thermal imager? I can feel if 3 of these loops are cold and 3 of these loops are hot.
Okay.
So when I fill it up with Freon, I like to go like this. And in my last video, I said, I'm going to put my hand on here and I'm going to feel it if it's hot. Then I know that the condenser's full.
Exactly.
It's not super hot. We're only talking about 100, 110 degrees. But hot enough for you to feel the difference and say, yeah, I can feel Freon's there. Yes.
Why does it get hot?
Because the refrigerant's under pressure.
Okay. And,
Raise the pressure, you raise the temperature.
okay. And
Okay.
another thing too
R134A, your temperature pressure chart, at 100 to 120 psi is going to be about 100 to 130 degrees.
what I'm getting at is just like, you know, if you got product in there, you just expelling heat. The gas is sucking out the heat.
You don't need product to expel heat.
Yeah, I'm just saying, just the process. That's all.
Yes.
Yeah.
So
Hey Richard, I think I missed this part, but before you do the nitrogen part, are you recovering or recharging?
Well, we recovered before we did service on the system. Before we took anything and changed the compressor, the condenser, compressor, condenser, the dryer filter, before we did any replacement or repair of this stuff, we recovered the Freon that was in the machine. Now that there's no Freon in there, we can service it.
all right. So what's
so you would service it with the nitrogen,
No, sir.
or would you recharge it?
No, sir. I would service it like I take the Freon out, and then I would change the condenser. It's almost like a washing machine. I take the water out before I change the drain pump, right? So I would take the Freon out before I change any part of the system, because if I cut this open, the Freon's going to go out. Now the nitrogen is after I'm done repairing and replacing something.
Nah, check to see if I got it.
I put nitrogen after I put it all back together to see if I put it back together right, because I'm using a torch and I'm brazing these joints together and want to make sure that the work I did is not leaking.
Okay. So
Yes.
I had a question about the recovery.
Okay.
Now I've seen some gentleman, a specific gentleman that deals with sub-zeros. He recovers the Freon and he reuses
You can.
the
Yes.
Freon.
And we just talked about that a few minutes before you came in. And recovered Freon can be reused. According to EPA, if I recover Freon out of this refrigerator, I can reuse that refrigerator for this refrigerator. But according to EPA, they don't want you to take the recovered Freon and go down the street to someone else's refrigerator and using it there.
But that's the same thing we do in automotive. In automotive, you go in, we hook up the car to a recovery machine, we pull all the Freon out, clean it or what have you. It sits in there, and then when we repair the evaporator, the condenser, whatever it is, or compressor, along with the orifice tube or expansion valve in automotive, we put the Freon back in, and then we might top off. So
Yeah, but see, they don't have capillary tubes where it's 10 times more critical cap tube
Exactly.
systems than orifices and expansion valves. You got a little bit of moisture in there. Automotive mechanics don't really care about that.
exactly.
They don't really think about it. They do pull a vacuum on it, but if it's leaking, we'll just fix it. You know, it's more critical on refrigeration system, the charge and how you service it, because so many people have so many problems after doing service that they're not following specific procedures the right way. They're doing this and they're doing that, but they're not doing this. And there's nothing to say, well, I didn't have nitrogen, so I'm just going to pull a vacuum on it. Yeah, you can. But maybe just put an ounce or two of Freon in there and just see if that leaks. Then recover that and then evacuate to the right vacuum. Now going to your dye question, this is a black light for the dye, and you would take this black light and anywhere you would see like this fluorescent green or yellowish looking reflection, this one's not going to have any in there, but this black light would reflect that and tell you. But here's a problem with dye. What if my condenser's leaking right here? My fan is running, and the fan goes like this, and it splatters that dye all over my compressor. Now everything is green.
Seen that.
So, yes, a dye will work. Hopefully, that you only go to a dye when, let's say, you charge your refrigerator, and a month later the customer calls you back and says it's not cooling. So you pressurize it, you look for a leak, you can't find a leak, you charge it again, a month later she calls you back and says it happened again. So now you're like, man, that leak is so small. Now I'll go to a dye because that leak is so small, it might just show up right here. But when you're doing service, sometimes them leaks are pretty big, especially if you can't see behind what you're doing. So that could be a big mess if that dye gets everywhere.
Exactly.
So I particularly don't use the dye, but sometimes we have had to use it because we just couldn't find the leak anywhere else. Yes.
What if you use a UV filter?
Yeah,
A UV filter is the dye.
Yeah, that's what I'm saying.
The filter itself just has the dye in it. So once the refrigerant flows around, that dyes the whole system. And if you have a big enough leak, it comes out
Just
with
like-
the Freon
you know how you got ink
and
pen?
sprays all
It's
over
a
the
blue
place.
dye that's mixed in with the additive.
So
So,
that Freon mixes with the dye, and then once you have a leak, it's everywhere. So that there's drawbacks to it and there's positives to it, but I would say don't use the dye if you don't have to use the dye. Only use the dye when every other procedure you did fails and you say, I got a leak, I just can't find my leak. Because like this pipe goes in the wall here and comes out the wall over there, there's a line running in the wall. Sometimes they have leaked. They don't normally leak on their own. I do know that one manufacturer, I'm not going to say names because it's going on YouTube, but one manufacturer, the screws for the hinges on the freezer door and the line were so close together, the screw would cut the tube just a little bit. And over a period of time, that tube is rubbing up against the screw on the door hinge and it leaks in the cabinet. And when it leaks, it's not repairable. They have bypass kits, but you can't always put that bypass through there because we use a vacuum pump to pass it, and you got a hole halfway through the tube. So your vacuum pump is not pulling it like it's supposed to. So, any other questions? Because I want to get into actual charging of this.
You said there was an electronic device to see if there's like leaks in the system?
There's an electronic leak detector that beeps. We'll do a different day, different class on that. It's good, but just like the dye, if the fan is blowing the dye everywhere, if your leak is here and you use an electronic leak detector here, the Freon's being blown throughout the whole system with the fan. So your leak detector, no matter where you put it, is beeping, there's a leak. So again, especially in a car. Car got the engine cooling fan or those electric fans and they're running and you're trying to find a leak.
And then it comes to the vents in the car when it's leaking from the evaporator.
Yeah, that you know where your AC cools you? You put leak detector in there and if it goes off, usually the evaporator, which is the part inside underneath your glove
behind
box,
the dash.
that needs to be replaced. Okay, so going back to what I was stating here is that I connected my vacuum pump to the red hose and I connected this to the yellow hose and then I run the pump. I got all my lines open and not only am I pulling vacuum on the refrigerator, but now let's say my refrigerator is already evacuated. Now I'm just pulling on the red hose to the tank. I let it run just for a minute. I close this one off, which is closing off between the red and the yellow hose. Now, my hose all the way up to my tank, all the air has been sucked out. So this red hose doesn't do anything. I'm just going to disconnect it just so you can see. As long as this gauge is closed, I'm okay. I don't need this pump anymore. I don't need this red hose. But now my tank is connected to my charging port on my gauge, and the low side is connected to the refrigerator to charge it with Freon. And there's no air in any of my hoses, because what most techs would do is they'll connect their tank and they'll crack this hose and they'll open the tank and let the Freon push the air out. You're purging the air and you're letting, Freon out. It's considered the diminished release, so I'm not letting any Freon out. I'm not losing a drop.
Did you come up with that idea yourself? 'Cause that's a good idea. That's a great idea.
I'm sure other people have done it, but yeah, I came up with it myself. I mean, doing this for many years, you try to come up with ways to make things work for you. So, reading the model and serial number plate, it says 4 1/4 ounces of Freon. First thing you want to do is I can put it upright or down. When I charge it, the tank has to be upside down. I'll explain that in a minute. But the first thing I want to do is I want to know how much Freon I had in my tank. Because when we go to EPA, pause it please.
R600
Go ahead.
and R134A.
What'd you say?
Since we have like R600 in some systems and R134A in some systems, do we have separate recovery tanks for each type of refrigerant?
For different gases, we have different recovery tanks, but 600A we do not recover.
Oh, yeah, because you
600A is vented into the air and preferably vented out the customer's home. You have a long enough hose, you run it out the window or the door, and you let it outside. Because that has an isobutane, we don't recover that. And EPA says it's okay to release that into the air. It's not EPA thing. So what we do is we turn the scale on, and I'm waiting for it to.
Let me ask you another question, Mr. C.
Okay, wait a minute.
Look at, I haven't had a chance to even do any work on a 600 system. As far as they got something they call, what those,
We'll go over the 600.
Mhm.
That refrigerator in the office is 600.
lock ring.
And yeah, we have lock ring. So what we do is we turn the power on and we zero the scale right now as it is. Make sure that our scale, just like you're using an ohm meter or something, make sure your needle's on 0 before you make your test. And we're gonna put the tank on it. And what we want to do is we want to see how much Freon in there. And that's about 15 to 14.75 ounces in 15 pounds, 0.75 ounces. No, actually, it's 10 pound, 15.5 ounces. So I said there's about 10 or 12 pounds in there, right? That's pretty good. I can just use this. I don't need a scale. Okay, so now what we want to do is when we want to charge it, I'm going to do two things. Notice this hose has a hand valve on it. Okay, this is important. I'm going to close my hand valve and I'm going to open my tank. The reason why is I want to charge the system with Freon, right? If I open up this tank, I need to know how much I'm putting in here. I already weighed the tank, 10 pounds, 15.5 ounces, almost 11 pounds, okay? So if I open this, Freon's gonna start coming into these hoses. I'm gonna say, how much went in the hoses? I don't know. Maybe an ounce, maybe 3 ounces. I could probably tell by weighing it on the scale But what I did is I shut it off here, so when I open it, there's really nothing in this. So now I'm gonna control the flow of refrigerant by the hand valve coming off my tank. Okay? Now this is what you do. 4 1/4 ounces need to come from this tank to this refrigerator. I had how much Freon in here?
12.
10 pounds,
15.
15.5. Okay, subtract 4 1/4 from 10, 15.5, or just 15.5. That'd be, wait, what's 4 1/4 from 15.5? That'll answer your question.
11.50.
11 1/4. Because 15.5 and I'm taking 4 1/4. Quarter from the 5 leaves me a quarter, and 4 from 15, so 11.15. So I could go down here till it says 11.15 or 11 1/4. Or what I do now is I press 0, and now I set the scale. Zoom in on that, Javon. I set the scale to read 0 right now. By doing that, I know as an ounce leaves, the gauge here is going to say -1 ounce because it dropped 1 ounce.
Exactly.
So I'm going to open up my gauge right now. No Freon's coming in. Why? Because the hand valve is closed. So I'm going to go here. I'm going to watch this gauge, and I'm going to watch till it goes -425. And I'm sure you have to watch it like this. It went a little bit over. It went about 5.
It'll let you know how much you need charging back
The
in
model
on
and
the-
serial number plate
yeah.
tells you exactly how much Freon to put in. Yes.
So what's the process if you want to use a charging cylinder? Like you want to be super efficient.
The
you get you a
charging cylinder,
charging
the
cylinder?
dial a charge,
Mhm.
that's the next
Okay.
lesson.
All right.
I'll go through that. So I put a little bit more than I should, but remember I said that the tank had to be upside down because when it's upside up, the vapor's on my hose. I can't weigh vapor. I can only weigh liquid. So I turn it upside down so liquid only flows out. So I'm about 5 ounces. I'm a little bit about half an ounce over than what I'm supposed to put into the machine. So I'm going to close it off here, and I'm going to let the refrigerator suck any remaining refrigerant out of the gauges and watch my pressures. If my pressures are a little bit high, I'm going to have to let a little bit out. Okay, I overcharged it. What are some of the indications if the unit's overcharged? What would I see on the system?
Freezing up.
Suction line would have excessive superheat or no?
I forgot the definition of superheat, but I know it would be freezing up. Yeah.
Superheat means what?
Too much.
I forgot.
Okay, you guys have to look it up. I'm not going to give you the definition. But superheat, remember we had to learn that superheat, subcooling, and everything else.
Yeah.
Superheat means there might not be enough refrigerant in the system.
Might not be
Okay.
enough.
So I need you guys to look it up and tell me what superheat means. So now we're going to plug the refrigerator in. Can you hand me the cord on the other side there, please? And I'm going to let it pull the refrigerant out of my gauges. Okay, so now I'm going to watch, and as the refrigerant comes out, you can actually feel it get cold. I normally, when I charge a system, like to put my hand on here. I like to know that it's getting warm and it stays warm. If I feel it get warm and I've charged it with a measured amount of Freon like we did, and the heat goes away and the tubes get cold again, I have a restriction.
Yeah, that is not consistent.
If it doesn't get warm and stay warm, the compressor's constantly pumping in there, then we have a restriction. All the Freon pumps in here and it stays trapped in here, and because it's not continuing to flow, it doesn't produce any more heat, yes?
So does the nitrogen, when you do blow it through with the nitrogen, does the nitrogen have the ability to dislodge any type of restriction, or?
Sometimes in a capillary tube if it's not that bad.
Now I've seen guys specifically focus on cleaning out the capillary tube. They get all the.
But when they clean out the capillary tube, and I'm gonna let this run a minute before we look at the pressures. Let's talk about that. Let's say I have a restriction in my capillary tube. If it doesn't blow out right away, I had one customer that had a lot of oil in that capillary tube. And I kept blowing nitrogen through it, and I would hold a paper towel and it would saturate my paper towel with oil. Let me ask you a question, where'd it come from?
Pressure.
Now the second question, why did I have so much oil there?
The dryer.
Why did it leave the compressor?
Because you have moisture in there.
Not because of moisture.
The valve in the compressor?
No, okay. Oil's pretty heavy. So oil's gonna sit in the bottom of the compressor. But if the condenser runs dirty, or the condenser fan's not working, or the compressor's a very hot environment, everything's runs hotter than it should. So the oil in that compressor starts to turn to vapor. A little bit of vapor oil always flows through a system, always. But if you get enough to clog your capillary tube, your compressor overheated.
So you're saying that a dirty condenser would allow the compressor to start overheating, and then the oil would start traveling through the system.
Well, if the condenser's dirty, what happens to the temperature of my condenser?
It's getting hot.
Getting hot.
Right.
What happens to Freon pressure when it gets hotter? Pressure goes up.
Right.
So the head pressure, the pressure coming out of the compressor rises because we can't get rid of the heat. Okay? When your head pressure rises, your temperature of your compressor rises because it's pumping at a higher pressure. Okay? Now, when a little bit of that oil starts to create a restriction in your capillary tube, because now we got too much oil flowing around, we get less oil on the low side, we start pulling into a vacuum. And in the compressor, it needs that Freon to go around the outside of the windings and the pump to keep that compressor cool. Okay? So the refrigerant in vapor form cools the compressor down. So if we start to get a little restriction, less Freon flowing over the compressor, more oil flowing out of the compressor, so that restriction gets bigger and bigger and bigger. So when you got a capillary tube or a low side system that's got excessive oil, you got to change the compressor, possibly the heat exchanger, which is a capillary tube and suction line. And I usually say, if I got to change that, I'm going to go change the evaporator too. I'm going to change all of that.
Yeah, we had that. It's not too long ago. You got one sitting in there now. I was thinking about just trying to change that compressor because he put more oil in that old compressor, and it was like, just put the old compressor back in after he did all the other change out. But I want to try putting another compressor and see. I think it's already been condemned, but I like to
Stop tape. All right, so we did a charging method with using a Freon tank and a scale. This is another method called a dial charge. I talked about this a little bit in the lecture from last week. And I particularly like this method because they even had a smaller one. It was only about this big that you could fill up with about 12 ounces of Freon. And you could walk into a customer's home with just that instead of this big heavy tank of Freon. Okay, you keep this in your truck. But when you get this thing brand new, it's 30 pounds. And you're carrying this, a compressor, torches, vacuum pump, recovery machine, recovery tank, scale. I used to have a hand truck and everything in a box. I put that and I'd wheel it to the customer's door so I don't have to walk to my truck every time I needed to service this. So in order to use a dial charge, you have to charge the dial charge. Now usually when there's no refrigerant in it, we would hook a vacuum pump to the valve on the top here, or we could do the bottom, and we pull a vacuum on it, and then we're going to charge it with Freon. So I'm going to show you how to charge with refrigerant in it. I'm not going to do it exactly like you're supposed to, only because there is a valve at the top, like I showed you here, and there's a valve on the bottom. The valve on the bottom is the main valve you guys will use when you're charging a refrigerator. Okay? When we charge the dial charge, we're going to use the valve at the bottom to charge it from the tank. But what the dial charge is a way to measure the refrigerant. You actually see the charge. Where when we're charging with a scale, we're relying on the scale to measure the refrigerant in. I can actually see the refrigerant in here. Now, it looks very big, but really there's a glass tube that runs from here all the way down to here, and the refrigerant's only kept in that glass tube. It's like a pipe but made of glass. You really can't see the Freon in it, and when I do fill it up, it's a little hard to see because Freon is colorless and odorless. So you can see it when you look close. It looks like water. There is Freon in here right now, but you don't see liquid Freon because I can see here that there's pressure on the system. If I go like this, that's Freon coming out in vapor form. But when we charge from here to a refrigerator, we want to charge liquid. Just like the tank, we cannot measure vapor. We can measure liquid. So first thing we'll do is we want to charge it. And we're going to take one hose and connect it to our Freon tank. Can we use our recovered Freon? Yes. Okay, connect it to our recovered tank. And I'm going to connect the next hose like this. Well, sort of. There you go. Now it's connecting. Now, here's the problem that we have with the refrigerator. I connected the hoses. I haven't opened up anything yet, but there's air in this hose. Okay? Now, if I hooked up my gauges the way I showed you, where I had the vacuum pump hooked up and sucked the air out of the lines, I could go through all that, but I'm not going to do it this time. So what most people did, the old school way, is called purging. We were talking about purging before. Purging is using the Freon to push the air out of the hose. So I just cracked the hose just a little bit. This valve is not open right now. I've just got the hose. And I go like this. And let a little bit of vapor Freon out. And it pushed the air out of the hose.
Oh, that
Okay.
red hose?
The red hose. There was air in here, but now the Freon from the tank pushed the air out. Okay? So now I'm going to turn the tank upside down because I want liquid to go in here. Normally all you would do is open this bottom valve and liquid would flow from here to here and start to rise up. And let me just move these rubber bands just for a second so I can show you. But the thing is that the pressure of this thing here says it's about almost 80 psi. And this one is about the same pressure because they're both 134A. They're both in the same room at the same temperature. So really what you should do on your top valve is this should go to your recovery machine and your recovery tank, and you should recover this and have nothing in there. But what guys would do is they'll purge some vapor off of here like this and zoom in on that. And if you look closely, you can start to see the liquid starting to fill up this tube now. I'm gonna let it fill up. Now normally you keep this, you fill this thing all the way up, and this thing holds about 2 or 3 pounds of Freon. And now you can use this for, if it's 3 pounds of Freon times 12 ounces, no, 16 ounces, you could probably do about 10, 15 refrigerators with just this $1 charge. Okay, once you've done this, I'm gonna do this. I'm gonna make sure this is open a little bit more. Try to get as much out. Now here's the problem with charging a $1 charge. I got Freon in this hose. They want you to have hand valves so when you take this hose off, you don't lose the Freon in the hose. These new tanks, they didn't have, now they have check valves so that you can't put the Freon back in the tank. That you would like naturally feed it. What people did back in the day is when the tank empty, they'd fill it with air and keep it in their car. So if the car tire was low or the bike tire, they'd fill it air. They put check valves in there now so you don't do it. These tanks aren't designed for reuse. They're thin-walled and they're not used for, they're dangerous. So I'm just gonna crack it a little bit, but I'm gonna lose a little bit of Freon that was in this hose. Nothing I can do, okay? But I didn't lose a lot. All right, the tank is closed, the hose is off. Now this is what the $1 charge is, what it does, and how to use it. First of all, we want to know the pressure, and if I look at this gauge, it's about 80 psi. Can you zoom in on that gauge itself?
Yeah.
It's about 80 psi, just over 75. And the reason why they call it $1 charge is because you can rotate this like a dial. And at the very top here, they have pressures, okay? And if we keep going, This is PSIG, pounds per square inch gauge, and we want to go to about 80. And this is 70 here, 80, 90, and you line the 80 up with that glass tube. So whatever the pressure says here
That's what you line up.
is the pressure you line up with your glass tube. Now you can count the ounces and pounds that you have in there, and I'm going to lift this up so you can see it. My liquid is right there. So I'm going to just use one rubber band to say that's where the liquid level is. Okay? Now each one of these lines are 1 ounce of Freon. They say 4 ounces, 6 ounces, 12 ounces, 1 pound, and that's 1 pound, 4 ounces. So actually I got 1 pound, 1, 2, 3 ounces. It's just about right there, 1 pound, 3 ounces. Okay? So the dial charge is there. How much Freon did we say the refrigerator takes?
4.75.
4.25 ounces. So then I go down here and I count 1, it's here on this line, 1, 2, 3, 4, and they have little lines there, 0.25 is just right about there. So you put the rubber band right there, and when the Freon goes in the refrigerator, this liquid line's gonna drop. When it drops to that rubber band, I close the valve, I'm charged. That's it.
Would you say this one easier than the other one?
It is easier than a scale. You carry the scale in a 30-pound tank in someone's house. I could carry this. Don't need a scale. Now, someone asked about this plug here, and the plug, it has a heating element inside of it. If you're trying to charge in the north, and you're in a basement, and it's 40 degrees in the basement, your pressure is going to be real low here, and it's going to be hard to get the Freon to go inside your system. So you plug it in and let it sit for about 5 or 10 minutes and let it reach maximum temperature. Your pressure gauge is going to go up. You're going to have to dial the dial charge to what the pressure is. Then you can measure it in. This is for up north. We're down in Miami. We never have to use that. So once we do that, I want to go ahead and want to connect my dial charge.
So you always set it to whatever the desired Freon, like 4 point whatever. I
Well,
guess in this case-
whatever the model serial number plate says the refrigerator takes, you look at the volume, and the volume, I'm going to put this rubber band at the volume, and then you count down 1, 2, 3, 4 1/4, and that's how much is going to leave this machine and go into your refrigerator.
Someone's gonna leave that machine going to that refrigerator.
Yes. So we're charging with this instead of charging with the tank. Now, I connected the yellow hose, and just like before, there's air in my lines. Not in the blue line, but in my yellow line. Now, I can purge it, but if I want, I'll just do the vacuum pump method real quick. Just connect up my high side gauge. And I'm going to go ahead and connect my vacuum pump.
That's to get all the air out the yellow one?
Just the yellow hose. So I'm going to open up the high side gauge. I'm going to turn on my vacuum pump. It don't have to be like 30 seconds a minute. Just let it go. Listen to it. Tell me when you think it's ready. I might have a little leak. The hose might not be tight. You heard it gurgle and then stop?
Mm-hmm.
Check my hoses. Maybe the seal on the end of your hose is burned. I did a video and talked about those hoses. Sounds pretty deep, doesn't it?
Yeah.
Okay, so then I'm just going to close off the high side first, then turn the pump off. So whenever we got machines running, we don't turn the machine off first. We close the gauges and we close all the valves first, then we turn it off. Okay, so now I want to open up the blue gauge, and you know what? My refrigerator's not in a vacuum. So I have to open this up. I just noticed that we were on 0. So we didn't pull the vacuum on the refrigerator yet. Before I charge it, remember we would purge with nitrogen, then we pull a vacuum on. So I'm going to just let it run for a minute just so I can show you the charging process. I'm not going to go to a full vacuum.
So after you put nitrogen in it, you should vacuum it too?
After you do nitrogen, you let the nitrogen out, then you pull the vacuum.
Okay, so.
Because when you let the nitrogen out, it's going to be at 0 psi. It has to be in a vacuum before you can charge it.
Okay.
If it's at 0 psi, it means the pressure inside here is the same as the pressure outside here. That means there's non-condensables in our system. Moisture, air, whatever.
So after you nitrogen it, you vacuum it, and then you would recharge it.
After
vacuuming.
nitrogen, you evacuate it, then you charge. Okay, so right there, I got a vacuum, and again, normally I would use a micron gauge and measure it. I'm just doing this for charging purposes. So I'm closing the high side off. I don't even need this red hose, just so you see. We're not using the red hose or the vacuum pump or anything. We're just going from the dial charge and the yellow hose through the gauge into the refrigerator. I've opened up the low side. Now I want to control the refrigerant. So I have it marked here and I have it marked here. When I open this, the refrigerant here is going to start to drop. When it gets to there, I close this, I'm done. So I open this up. You hear the freon going in the fridge? Look, can you see it going down? Now, when it bubbles, you want to close it for a second to see how far it went. Not air, the refrigerant is evaporating. It's turning to vapor up here. So that bubbling is not air. We have no air in the system. It's a refrigerant turning from liquid to vapor. So if we look now, we're still got about an ounce or two to go. So we're going to do it again. Close it up. Give it a second. And I think we're right about on the money. Right about, isn't it?
Mm-hmm.
So then, we're done. We're going to go like this. Can I have the refrigerator cord, please? Go right here in front of you.
This cord.
Yes, sir. Now, I charge with liquid. We don't do this when the compressor is running. We could damage the compressor. A lot of people say, oh, you just charge with liquid. You're going to go ahead and plug it in right away? Refrigerator's in a vacuum. The liquid's not going to go into the compressor and just sit there. It's going to just start flowing all around. It's almost like an accident on a freeway. Once you pass that accident, you got 5 lanes on that highway you can choose. It's going to go everywhere. Same thing as freon. When it goes in the compressor, it's not going to sit there as liquid. It's going to expand as vapor throughout the whole system as fast as it goes in. You wait 30 seconds or something, you can plug it right in. You're not going to hurt anything. So I'm going to take this, plug the refrigerator in. We're going to watch our gauges. We're going to feel our condenser. Watch out you don't hit the fan or nothing. And we're going to see if we get down to about 0 psi. And we're done. And right now, any refrigerant that's in my hose, I still have this open. So any refrigerant's in the hose up to the gauge is closed. So I'm sucking any remaining refrigerant out because I could still have a half an ounce sitting in this hose. But once it gets down to about 0 psi, there's no refrigerant left in the system or in the hose.
Mr. Z, when you recharge or even recover, would you say like your 2 main hoses would be the blue and yellow?
Well, you'd use the red too if you had accessibility to the high side.
Okay.
That would speed up charging, evacuating, the whole 9 yards. But most technicians only put 1 valve on there because it's extra work to put another valve.
Mm-hmm.
But if you have a sealed system problem or restriction or something else, you want to go ahead and put 2 valves on it because you want to know what both sides of the system are doing.
Yeah.
Because even though this one's going down, this one's supposed to be going up.
Mm-hmm.
And you want to see that you got pressures on both sides.
Mm-hmm.
So if you have a problem with the system, you go on the low side first.
Okay.
If it's in a vacuum, you want to add freon and bring it back up. If it goes back down into a vacuum, you don't know what's happening to the high side. Is the high side continuing to rise? Or is the high side staying still when you keep adding freon? If it's staying still when you're adding freon, we're in a restriction. Okay?
Mm-hmm.
But if it's going up and we're still pulling in a vacuum, we might have an air leak sucking air in. We might have another problem. So accessing both sides of the system are going to help us to try to identify the problem. Yes?
I was gonna ask, so why do you put that on 80, the dial charging?
Because the gauge here said 80, and that was the pressure of the freon inside. So we dial this to the same as this, because that gives us the accurate measurement of how much Freon is really in this dial charge. Okay?
Did
So
you
this-
ever put nitrogen?
No, we haven't done that yet.
Oh, okay.
This is, I'm not doing every step along the way. I'm just saying, how do we recover? How do we charge? Different charging methods.
But
and
we
everything
wouldn't need to
else.
put nitrogen if we haven't replaced anything.
What?
So we wouldn't need to put nitrogen. if
Not
we haven't
really,
replaced
because yeah, we
anything.
didn't really open up the system. Yeah, we recovered and we evacuated and we charged, but we never really opened the system up to the outside air to let air in.
Okay.
So you're right. You would need to do nitrogen, but we should do nitrogen just to demonstrate how to. In the
Yeah,
next
that's what I
class,
did. I wanted to
the
see
next
it.
class we'll do is a nitrogen
Yeah.
charge.
Please,
We're gonna do, the next one's gonna be leak detection.
Yeah,
I'm
that's,
gonna show you how to check with nitrogen, how to hold the charge, how to fill it up, how to leak check it. How do you know, like, if you're sitting there, we call it like a drop test. I do the same thing with gas appliances. If the pressure drops, we know we have a leak in the system. It doesn't tell you where, but tells you the system's leaking.
so
Okay?
what about, if you have a floating restriction, what is the best procedure to isolate or figure that out?
A floating restriction is difficult to find, and that's a restriction that I would want to take it apart and back flush it with nitrogen. I would have both
Got that.
valves connected, and I'd cut the capillary tube, and I'd put 100 psi of nitrogen through both sides, and see if both sides of the capillary tube got good pressure coming out of them.
Got
Because
it.
a floating restriction, remember, a system that has not had a leak normally don't even have valves on it. So when you have a restriction, it's not usually a moisture restriction, it's usually an oil restriction.
That came from the compressor,
Yes.
from overheating.
Because, I mean, your customer had a refrigerator 5 or 10 years and tell me that moisture been there 10 years and now it's causing a restriction. That's not happening. Now, a moisture restriction is either there was a leak in the system, usually the low side, so Freon leaks out when the compressor's off, but it sucks moisture in when it's running, okay? Or someone before you serviced it didn't evacuate it or recover or do everything properly, and now they created moisture restriction.
Wasn't there some type of, wasn't there like a certain product, excuse me, that had, they made one of the lines that went into the drain pan, like a little line? Like
Yeah,
on
they
the-
had they had the drain pan that had the condenser loop running through that
Exactly,
line.
and it would always,
Corrode,
exactly, and people would find a leak there.
yeah, but that usually that requires changing the compressor
Of
because
course.
you're getting moisture in the system.
Mr. Z, you know you said it's moisture in the system. Don't the dryer supposed to prevent that, right?
Well, the dryer's supposed to catch it, but
To
like
catch
the
it.
one she said, if the high side got a leak in the drain pan and it's sucking liquid into the drain, from the drain pan into the system, it isn't gonna catch droplets of water.
Yeah.
Moisture in the air, like humidity in the air, is very minute.
How does that happen?
That doesn't come in unless someone serviced it. Moisture doesn't go, this is steel pipes.
Yeah.
So unless the system itself corroded or had a leak, we had a problem where some of these houses were built with that Chinese drywall.
Okay.
And up north in Coral Springs, me and one of the guys who used to work for us, he moved up north, we're still friends. The copper tubing in their air conditioning, their plumbing, and the refrigerator all turned green and corroded and leaked. We had it in a sub-zero refrigerator change the evaporator, the heat exchanger, the condenser, and every line.
Is that
Wow.
algae? Can that be algae buildup?
No, that's the actual copper tubing. You see the color of copper?
Yeah.
It was turning green.
So basically, you said
Not green like algae. It was like a powder green. If you touched it like this, you'd see like a powder color in your fingers.
And that's because of the drywall.
That's because of whatever's in the drywall was interacting. They had to,
Bacteria. So.
it was messing with their air conditioning system and everything else. The builder that we were doing work for had to completely gut all the drywall in the house and redo the whole interior of the home. Stop the video.